everyone, how are you all? Welcome back to the channel. Today I'm starting a brand new chapter, determinant, right? So determinant itself is a very powerful tool when it comes to linear algebra, right? While dealing the questions of matrices or the properties based problems or system of linear equations questions. Okay, so whenever you see these type of sums, they are easily solved by use of determinant. Now if you are somebody who feels this way that sir, some of the questions of determinant are very easy, like very easy, and other kind is very difficult, up to that level that we skip those problems, do you feel that way? Do not worry, by the end of this chapter you'll have no confusion as such. Okay, so if you want to unlock the real power of determinant, like this video, subscribe this channel, and let's start this session smart way. So in the planner today, we have part 1. We're gonna end up learning today finding determinant of 2x2, 3x3 matrix. Later we'll move on to learning the concept of area of triangle. How do we find that? Use the help of determinants, and what's the relation of that with the coordinate geometry, right? Usually we find area of triangle with the help of coordinate geometry. Okay, so we'll learn the relation over there as well. And last topic for today will be collinearity. Again, we'll solve questions on all these topics. I've taken a total of 9 to 10 questions today. We'll solve all of them in detail. Okay, and of course part 2 will be another concept session, will come after this video. Okay, and part 3 and part 4 are your KCET and JEE mains PYQ that you know very well. Okay, so now why are you all here learning from this session? It's very simple, because we at Diksha Karnataka have produced a very good result last year. Okay, so all your seniors are the achievers of these top ranks. You can see Prajwal is there at 171, and there are so many names and more than that we can't put in this particular sheet. Okay, so the point is that all of these students you see, all of these choppers you see that are going to join the top colleges across Karnataka with their choice of stream, whether CS, whether ECE, whatever their choice. Okay, so they're going to do that. We are helping them right now in the process of counseling. You can see the counseling sessions are already being conducted right now by Yasmin ma'am and Aspirants ma'am on our platform. So my point is, all these students you see over here are actually or were actually in the same place where you are today, right? So all these were at the same place, means they were also confused and unsure about what to do, whether what you're doing is right or not. So what was the difference over here? They trusted the process. They really believed in what they're doing, the learning process, and they ended up with consistency and getting these good results. So if you want to be something like that, if you want to achieve a great rank in CET, whatever is your goal, let us know that in the comment section right now. I understand that this is a recorded session, but you can give me your target, your goal in the CET or whichever exam you're opting for in the comment section. Okay, now we can start with the session right now. So session, if you see, today we have the chapter insights. Again, what are the most vital role the chapter determinant plays in the, let's say if we talk about exams point of view. So first thing will be, of course, questions of area of triangle and collinearity. Okay, very important in KCET or JEE. There are some direct questions as well, not just like difficult ones. There are some very much direct questions are coming in examination, especially in the KCET. So there is a direct question that you can expect from this topic, and solving linear equations. Okay, this kind of question is also there, which is also used with the help of inverse of a matrix method. We use this approach to get the solution of linear equations. Have you seen those questions? It is very important for your board's point of view as well. So these 3 topics are one of the most important topics when it comes to chapter determinant, right? Now what next? So if you see the session today's session will be a very basic session. The very first session we'll talk about determinant of 2x2 and 3x3 matrix, different approach to find them, and some important points, some important properties of determinant, and then we'll move on to the question practice. That's where I want your complete attention. I have some homework also for you. You have to answer that in the comment section once I show you the work. Okay, so let's start the session right now with the introduction. So what we have, determinant is what? It's a scalar value associated with only square matrix. This is very important. So 2 terms here we have, scalar value. Okay, now this can be a complex or real number. Okay, this can be a complex or a real number. All right, and this is associated with what? Associated with your only square matrix. Only square matrix. So if you have a question in which matrix is given as 3x2 order or 2x3 order, and they ask you to find determinant, you can say not possible, does not exist. For any non-square, basically a rectangular matrix, what happens is the determinant does not exist. Is that clear? Okay, let's see. Determinant is a scalar value that can be obtained from the elements of a square matrix. Okay. So again, this scalar value determines whether the system of one of the application is given over here, whether the system of linear equations given in this form does have a unique solution or not. Basically, we also look for consistent and inconsistent forms, but that will come later. Right now, just understand one of the applications this is given over here. This is one of the application of the chapter. We have again others as well, but one application of the chapter determinant is given over here. We get to know without solving the linear equations whether they are consistent, whether they are unique solution existing in nature or not. Okay, and sometimes this approach of determinant comes very faster than the conventional approach of linear algebra. Okay, determinant to every square matrix A, the element is given like Aij, that you know that, of order n. It's a square matrix. We can associate unique, real or complex number. I already said that the number can be a real number as well as complex number. If it is given in the form of variables, let's say A, B, C, D like this, of course the result will be in terms of those variables only, right? I'll show you that, don't worry, in the examples that I've taken. Now, so we have, let's say if I have a matrix given like this, A, it's a 2 cross 2 matrix. 4 elements are there, A, B, C, D. Then how we write in determinant form? Simply put, remove the brackets of matrices and put this bars. Okay, it's not modulus. This is not modulus. It is basically determinant of the matrix A. This symbol is not modulus. Consider over here. We call it as determinant of the matrix A. Okay, how do you find it? That will come later, don't worry. So of course only square matrix has a determinant. First point to remember, and second point is this is not modulus. What you see over here is not modulus of A. That's a different thing. Okay, modulus is a different function itself. Determinant is a, it's a tool, it's a operator that gives us real or complex value. There's a difference in both of them. Okay, so this is clear. Moving on. Now, how to find the determinant of various other types of matrix? For example, we can have what? We can have a matrix of order 1. Order 1 means 1 row, 1 column. 1 row, 1 column means only one element, right? Only one element. So for all these type of matrix, what is the determinant value over here? Simply the value itself. So if I write here, if this is my matrix A, my determinant of A will become simply the value, the element itself which is given to you. So 2. Okay, this will be the same value. Okay, same here. If this is my matrix B, my determinant of B will become, simply the element itself. This is case of 1 cross 1 matrix, basically order 1 matrix. Okay, now if we move on to 2 cross 2 matrix, if we are talking about 2 cross 2 matrix, what happens there? We simply do cross multiplication. Okay, A1 into A22, A11 into A22, then we subtract this product. What I'm talking about is, if I'm looking for the determinant of A, I'll do A11 into A22, there comes a sign of minus, which is subtraction, A12 and A21, A12 and A21. This value, this outcome of this value will be simply your determinant. Okay, we have taken example, I'll show you over here. So if I'm looking to find the determinant of the matrix A, what I get? 2 into minus 6, how much is that? Minus 12. 2 into minus 6 is minus 12. There comes a subtraction sign, then you'll start multiplying these two numbers. What is that? 3 into minus 5. How much is that? Minus 15, that's right. Okay, and we get what result? Minus 12. This will make plus, so plus 15, and we have the answer as 3. So for a given matrix like this, what did we do? We multiplied 2 into minus 6 and 3 into minus 5. A result is 3. Okay, this is what we did. And now same thing, if I do over here AD minus BC, this is in terms of the variable, this is the numbers when it's given. Okay, so this is how you find the determinant of 2 cross 2 matrix. Now moving on to finding determinant of 3 cross 3 matrix. That's where calculation parts comes in the picture. Okay, so again I want to say something. First of all, how many rows and column we have over here? We have 3 rows, row 1, row 2 and row 3, and columns again same way. We have column 1, column 2 and column 3. Usually we write the name also the same way, R1, R2 and R3. Over here we have C1, C2 and C3. Got it? This is that column 1, column 2, column 3, that already you know when I taught you the matrix part. Okay, So my point to write all this over here was very simple. So I can find the determinant across any of the 6. Are there 6? Yes, there are 3 rows and 3 columns. So I can find the determinant of this matrix given to us in any of the 6 representation, whether of rows or columns. Interestingly, the result will always be the same, whether you find determinant across row 1 or row 2 or row 3 or column 1, column 2, column 3. You can take any one. You can't have to take more than one. Only take any of the rows or column. When you do that, you end up with the same result every single time in all the 6 iterations, whether you use row 1, 2, 3 or whether you use column 1, 2, 3. Getting my point? Whatever you choose, result is always the same. Okay, and how do we find it? So what you do is, once you select, let's say, row 1, once you select the row 1, next step is to eliminate. Okay, eliminate. So of course, before eliminating, we have to choose the element we are talking about. So my first element is A11, right? First element is A11. So you'll write here A11. You write here A11 and then eliminate that particular row and column where the element is contained, also called as address of the element. Okay, what is the address of the element? A11, first row, first column. So remove the first row and first column. Okay, once you do that, your remaining 2 cross 2 matrix, you'll do the same operation, A22, A23. See here, A22, A23 and A23 and A32. Multiply like this and multiply with A11. Now what is this, sir? This is the sign of that particular, that element. How do you get that? Okay, that value, sign. Now that will depend upon this value A11. Means, remember A11 looks like this only, no? Aij, right? I can write A12, A13, A21, A22. Whenever you have I plus j value even, you're gonna use the sign positive. Whenever you have I plus j value odd, the sign for that particular value, this resulting value over here, this will be a value, right? It will be a number. For that number will be negative number. Getting my point? Multiply the minus sign to that. Okay, in this case, check here, 1 plus 1, odd or even? It's even, of course, so it becomes plus 1. Answer will be simply what? A11, the same matrix repeat, A22, A23, A32 and A33, and you know very well how to multiply them, right? So this is my, is this over, sir? Is this the value of determinant? Of course not, we have to do more, right? So what is that second element now? For the second element, was the address first row and second column. So then we're going to eliminate first row and second column. Now you'll write what? Same way you'll write here A12, okay, and your remaining 2 cross 2 matrix. Please check. First element is here A21, here second element A23, and over here we have A31, over we have A33. So after the elimination, whatever is the elements left to you, A21, A23, A31, A33, okay, write them in 2 cross 2 matrix, okay, and the sign over here, check. Sign of this 2 plus 1, odd or even? 2 plus 1 is odd, sir, hence there will be a minus sign. Okay, now the last one. Last element is A13. So right here, A13. So A13 has an address in first row and third column. We'll remove this. First row and third column. Now what is the remaining matrix? Please check. You have A21, A22. We have A31 and A32. I know I am going a little slow over here, but if you are somebody who gets stuck in this part, my job is to clear it. Okay, if some of you know this very well, do not worry, just give me some time, let me complete this part and then we'll continue. Okay, so as I said, this is a basic session today. We're gonna start from the very much, the very basic level. Then we'll, of course, in the sessions to come, we'll increase our level of understanding and problems. Again, you see 1 plus 3 is what? Even or odd? It is even, hence you'll have a plus sign. So yeah, this is your answer. Please check. Starts from here and like this. That's your answer. First element, second element, third element. Now, sir, do I have to remember always you have to add 1 plus 1, 1 plus 2, 1 plus 3? You don't have to. I'll give you a trick for that. Don't worry. So the trick is very simple. Think about it. Your element here. What's the first element? 1, 1 means plus. I have 1 2 means odd, so negative. Here again 1 3 means plus, and they'll just continue like this: plus minus plus minus plus minus plus minus plus. That's your symbol if you want to remember how to operate the symbols based upon which row or column you're taking. Understand this? Plus minus plus, minus plus minus, or plus minus plus. Okay, plus minus plus is alternate. Okay, that's how you remember the sign of the terms. If you don't want to remember, always 1 plus 2, 1 plus 3 is what, but of course that comes from here only. You can cross check. 3 plus 3 is even, so you have a plus sign. 2 plus 3 is odd here, so you have a minus sign, and that's all. Okay, that's how you find determinant of a matrix order 3 with the help of first row. Let me show you one where we're going to deal with first column also. For this I've taken a matrix itself. Let's call this matrix to be matrix A. I'm looking for determinant of the matrix A. What did I say to you? First I want to column 1, right? This is my column 1. Sign, remember, sign was given to you: plus minus plus, plus minus plus. You want to cross check. A11 is even, A21 is odd, and A31 is again even. 3 plus 1 is 4, right? That's my plus minus plus. So if I start with the second one, my number is 2 over here. There's a plus sign. I don't have to write that. Whenever you have a plus sign, you do not have to write that. Okay. Now, sir, matrix will order. Please check. Please check in the matrix order, sir. All right. I'll take in the matrix order only. So matrix order. So of course, what I have to do? The address is first row and first column. Remove that. I have matrix left is 3 5 1 2. Same way, I have to deal with the second element in the column. Okay, so have a look. This time we have 4 is there, right? But which element? This element means minus sign. Put here minus 4. Eliminate this second row now. Okay, because address for this element is first column, second row. What is the remaining matrix? 6 1 and 1 2. Okay, now how about the last one? We have plus 0. Of course we'll have a matrix, but does it matter? No, because if you take plus 0, no, whatever is the remaining matrix does not matter, because I'll become 0 only. That's why it's also told that whenever you're finding determinant, try to look for a row or column which has more number of zeros. If it has 0 means you have to do less calculations, right? So that's why I've taken this first column 0 over here. This is gone. Now this term itself is not required. Reason is very simple, because there's a 0 multiplied to this. Okay, so determinant of A now, continue. We have 2 times of 3 into 2 is 6, 5 into 1 is simply 5. I have a minus 4 sign over here. 6 into 2 is 12, and 1 into 1 is 1. Answer is coming as 2 times of 1. 6 minus 5 is 1, and minus 4 times of 11. Answer is 2 minus 44, hence minus 42. That is my determinant value as minus 42. I hope this is clear. Determinant of A is coming as minus 42. Got it or not? Yes, simple enough. That's how you solve whether you talk about column or row. I've given you both the understanding how to use that. Let's continue now from here. First question we can solve. So this I'll give you as homework. I've already taken a question like this, solved how to find a determinant. This will be your homework. So homework is this question. So question number 1, give me comment as your answer. Okay, give me the determinant. Basically right here, determinant of A is equal to what? Whatever is your answer, let me know. Okay, comment your answer in the comment section with your, this is your homework. Okay, question number 1, solve it and give it to me. Okay, how do you find this class notes? I hope you know that very well. If you don't know, if you watch this, if you're watching this session for the very first time, all the class notes, all the updates, all the schedule has been given prior only to all of you in the WhatsApp channel, and the link for that is given in the description of this particular video. Okay, so go ahead, check the description out. You'll have a link over there for the WhatsApp channel. Join that. It's a channel, don't worry about your privacy. It's not a group, it's a channel. We don't get any of your information. We just broadcast, we just give your all the data that we have to provide, class notes and schedules given over there. Okay, you can check, and without any problem you can attend all the sessions. Okay, this is done. Question number 1, it will be homework. You'll solve it, right? So get the class notes in the PDF format in the WhatsApp channel. Now important points to remember. Determinants obtained along any row or column is same. Sir, we know that very well. First one we know that, sir. Okay, second one, for easy calculations we shall expand the determinants along the row or column which contains a greater number of zeros. I told you this as well. Whichever row or column has more number of zeros, we have to do less calculations. So that's why we have to choose that doing the smart way. Okay. While expanding, instead of multiplying by -1 plus j every time, we can multiply by +1 -1 accordingly, as I plus j is even or odd. This also I explained you. This also I have explained you based upon I plus j is even odd. You can simply use that. Otherwise, you can use this technique also: plus minus plus minus plus minus and plus minus plus. This is used. This I've got using what? The odd and even only. Okay. The last one: determinants are not multiplied as you multiply matrices. Remember, matrices how we used to multiply? First row to first column, this is my first element, and like that. In determinant, their values, right? Let's say I have two determinant. Determinant of A is coming out as 4, determinant of B is coming out as -16. So here this will become what, dear? This is simply -64, because they are numbers, they are values, they are scalar values. Okay, you don't have to multiply like the matrices. So we don't multiply them as we multiply matrices. Simple enough, clear enough. Okay, now next we have few notes to remember, some important properties. So if you are dealing with a determinant when the matrix has a power, when the matrix has a positive integral power, what you do simply is take the power outside n as it is and find the determinant. Basically, you are asked to find determinant of a power matrix. Correct, na? Means determinant of a matrix with a power. What you do simply is find determinant of A and then you can take the power. Which is easier? You want to multiply A to, for example, if I take this case as A cube, let's say I have let's say here A cube. Okay, I have A cube. So what does this means? It means is find a determinant, find the cube of the matrix A first, then the resulting matrix that you get, you have to find the determinant. That is going to be challenging and long process, but what you can do simply is find the determinant of the matrix A and then take a cube, because this is going to be a simple value, right? It's going to be a scalar value, so you can easily multiply this to itself 3 times. So which is easier? The side is easier. That's why the property you can use it. Very, very important. Very, very important property. Next is if A equals to KB, same thing is there, where A and B are square matrices, of course for the same orders. Then what we have, determinant of A will be given by K power n. So see here, K, if I write here, no, they're saying that A equals to KB. If you want to apply determinant to both sides, no, right, this K will come outside as NB. K power NB. Why K power n? Because you're taking K common from each of the rows or columns. Okay, please check. The order is 3. N means what? It will have, well, let's say if I talk about n as 3, it means it will have 3 rows. So from each row you have to take 1 K out. That's why you have K power n. If you have to take 1 K out from each row, what are you going to get? You will have K power n. Okay. For any two determinants A and B, either you take determinant of the product, or you take product of the determinants, or you take in the reverse order, or you take with the transpose. Always all these results are the same only. Transpose, you take one transpose, both transpose, multiply in different order. First take multiplication, then you take determinant, or first take determinant, then you take multiplication. Does not matter. In determinant, result will be always same for any two given square matrix of the same order. Okay, right? All right. Of course, so let's say this is, what does this means? The result has to be a square matrix. If you find a determinant of something, let's say BA is coming equal to, let's say, a matrix X, then X has to be a square matrix. Let's say B and A are not a square matrix. That's all right. Of course, determinant, the multiplication of the BA should be defined. We have learned that in matrices, right? BA multiplication should be defined. For example, sir, let's say B order is 3 cross 2. A order is 2 cross 3. We can multiply them, right? What's the answer? What's the answer for this? Answer is going to be, multiplication will be BA matrix of the order 3 cross 3. So my point is, the multiplication should be defined and the result should be always a square matrix. Then only you can find the determinant. Got it? if somebody is having this doubt, sir, there's nothing written as any two matrix of A and B. How do you find that? Okay, so understand this. BA should be defined, and the result of the matrix product should always be a square matrix. Then only we can use the determinant property, right? So we have, of course, AB should be a square matrix. Here A and B should be square matrix. Here B and A should be, BA product should be square matrix. Understand that very, very clearly. Okay, now again same property, this is the same thing. If you have KA, here we have taken as KB, right? So if you take KA determinant, what happens is, based upon the order of the matrix, that K will come out with the same power. I'll continue like this. So if K is you're looking for a determinant with KA, okay, based upon the order of the matrix, you have to take the power of that constant K to that value, that order, and comes with the product of the determinant of A itself. This is clear. It looks very simple to you, but it is very, very important. It will be used a lot in the questions. Now let's solve some questions. What we have: find the value of x for which determinant A vanishes. What's the meaning of this? It means determinant of A is equal to 0. Equal to 0. Let's find that. So you can see here again, which row or column? Sir, I can either use third row or third column. Why that, sir? Because we have more number of zeros there. Which has more, sir? They both have same number of zeros, sir. So I can use the third column. Okay. So if I use third column for this element, I'm using the column number 3. Please check. For first element, 0 times anything, doesn't matter. Next, what we have, sign is plus 0, minus 0, again doesn't matter. And the last one, what we have, plus x, sign remember, right? Plus, minus, plus. So plus x, the matrix is left. You're going to remove this, we'll have matrix as x plus 1, minus 1, 2, and x plus 4. So multiply now, we get x times of x plus 1 times x plus 4, and we have minus sign, minus 2. Correct? I'm doing cross multiplication, right? Clear? Okay. 2 into minus 1 is minus 2. We have a subtraction over here. What we get? We get here x square plus 4, and we have 5x. So plus 5x plus 4, and we have plus 2 over here. Correct now? And of course this is given equal to 0, right? This whole thing is given equal to 0. How come, sir? They said it vanishes. It vanishes. Okay. Final step, what we are getting? We have x square in the bracket. We have x square plus 5x plus 6 equals to 0. Correct? 4 here. If you want, you can do the multiplication over here to get the result and factorize it. So we get x plus 2 and x plus 3 as 0. So my value of x is nothing but 0. From here we get minus 2 and minus 3. That's my answer. So for the values of x to be 0 or minus 2 or minus 3, if you replace this x value by any of these values, what will happen to determinant? It will become equal to 0. It will become equal to 0. Is that clear? Please check. Question number 2 is done. Question number 3 now. Question number 3 now. What they say? They have given two determinant to be equal. Now understand, this is not matrix. Usually what happens in the matrix, we just compare the elements, because we understand that in matrix, if they have given two same order matrix equal, it means corresponding element has to be equal. That's not the case here. It's determinant, because I'm telling you, I've seen the answer sheets of students and they say what? This is said 2x equal to 6, hence answer is 3. The answer is x equal to 3, and in this case it's not given, but you'll have an option like this 3. You'll pick that option, the answer is wrong, you'll get 0 marks. So what are you going to do? Find determinant first. Okay, don't take it that lightly. 2x square minus 8 times of 5, so which is 40. So this is going to be equal to 6 into 3. How much is that? 18 minus of 7 into 14. So 7 into 2 is minus 14. Okay, we have 18 plus 14. How much is that? 32. And we have 40 over here. So minus 40 I have over here. 2x square minus 40. This is 2x square. Bring 40 on this side. I get plus 40. So I get 2x square equals to 72. So I get x square equals to 36. So I get x equals to plus minus 6. Option is A. Option is A. Clear? Okay, simple question. Have a look, all of you. This is simple enough, very simple. Question number 3 is done. Now question number 4. Going a little faster? It's yes, we can do that, right? Simple questions are there. Now in this case, we have a complex factor to be introduced. What are we going to do? Something changes, sir? Nothing changes, same approach. What are you going to do? Find the determinant of this. So we're going to do this into this and this into this, right? Cross multiplication. Okay. So when you do that, we have a plus ib multiplied that with a minus ib, and we have next what we have? There's a minus sign, of course, id and minus c, and over we have id plus c. Why did I write like this? Why did I write like this? Because it forms a formula, no? X plus y, x minus y, x plus y, x minus y. Okay. So multiply now, we get here a square. There's a minus sign, a square minus b square. So we'll have over here I b the square. Here it comes a minus sign. Over here we get what? id square, and we have minus c square. Carefully look, a square. Square of I is how much? Minus 1. There's a minus over here, becomes plus. So plus b square. Got it? I square is minus 1. With the minus sign over here outside, it will become plus 1. Okay, so plus b square. Comes again minus d square over here, because I square is negative. So we get I square d square, right? I square negative means minus d square. Over here we have simply c square. Expand the bracket now. We have a square plus b square. Minus of minus becomes plus, so plus c square, and minus of minus becomes again plus, so plus d square. That's my answer. Option A is correct. Option A is correct. Option A is correct. Getting it? Easy enough. Okay, fourth is done. Fifth one now. So before I move to question number 5th, we have one more concept to study, which is area of triangle. Remember, you must have remembered this formula. You must remember this formula. You have seen this, right? Learned in grade 10 only, I think. Area of triangle, or is it cut off from the CBSE portions? Okay, but I think this formula was there in grade 10. Okay, so half of x1 y2 minus y3. If the concept is revised again, if the syllabus is revised, then they might have chopped this off. But usually this concept is there. Okay, so x1 y2 minus y3. So what we used to do, because I remember it like this. What we have learned, remember, when I was a student, I remember like this. We write here 1 by 2, sir. We write here x, sir, y minus y plus x, sir, y minus y plus x, sir, y minus y. Start from 1 to 2, 1, 2, 3, and here this is x1 means this will become x2, so 2, 3, 1, x3, 1, 2. So that's how I remembering this formula, because that's how my teacher taught me. Okay, so write xy, 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 and simply write 1, 2, 3, 2, 3, 1, and 3, 1, 2. So this was the formula that I learned in grade 10. So I hope you have learned it. That's how I find area of a triangle when the coordinates are given, when the coordinates of the triangle is given. Okay, vertex are x1, x2, sorry, x1, y1, x2, y2, and x3, y3 are the three vertex of the given triangle. x1, y1, x2, y2, and the last is x3, y3. If the vertex is given like this, that's the formula of your area. But I'll tell you what, using this method also you can get the same result and even faster. What you do is over here simply write x1, y1, x2, y2, x3, y3. Okay, write that, okay, in the matrix, the first two columns, and last you replace this by 1, 1, 1, because it's 2D figure, right? So 1, 1, 1. Okay, and simply what you're gonna do, find the determinant of this. If you do that, what are you going to get over here? Please check. You'll have x1, y2 minus, what is that? y2 minus this one, y3. Okay, same way, minus x2. What is it going to be? y1 minus y3. Over here, plus x3, y1 minus y2. Sir, there's a mistake, sir. There's a minus sign over here. Do that. Bring this minus sign inside. What I get? x1, y2 minus y3 plus sign I get x2, this is change, y3 minus y1 and plus x3, y1 minus y2. Now compare this whole thing with this thing. Is it same or not? 1, 2, 3, 2, 3, 1 and 3, 1, 2. So only thing is missing is 1 by 2. So do one thing. Write it like this and multiply it with 1 by 2. So basically if you want to find area of a triangle using determinant, area of a triangle using determinant, you write here 1 by 2 and the value itself x1, y1, excuse me, x2, y2, x3, y3, 1, 1, 1. That's how you're gonna find the value of your determinant. Sorry, value of your area of triangle using determinant. This is the property over here. Okay, I just verified for all of you how do we use this one to get the same result. This you know, right? This formula we remember, but how do we use determinant? Using this approach. Got it? Okay, so this is clearly visible. The same thing. Okay, so area of triangle is simple. Now based upon this only we have a concept of collinear points. We have a concept of collinear point. How come, sir? See, we'll have triangle like this using 3 points. We'll have triangle like this. Now we'll have triangle like this also. We'll have triangle like this also. So when this point keeps moving towards the other side, okay, this vertex, there will come a position when this point will exactly lie on this. So if I call this to be point A, B, C, there comes an instant when this point A comes on the line BC. Then what happens is, then this point becomes collinear. Okay, and beautiful thing is, you can see here area is reducing. Area over here, the area part is coming down. Okay, and in this point what happens? The area becomes equal to 0. How come, sir? It's not a 2D figure anymore. It's a straight line, one dimension figure. In that case what happens is, there's no area. You have only length of the figure. Okay, you can find the length of ABC, AC, AB like that, but you can't find the area of the ABC. Hence what we do is simply use the same approach from this is the value of your area, right? If it is a straight line, can you find the area? You can't, because area is equal to 0. This is the area formula, equal to 0. What it means is simply that if you can find determinant to be equal to 0, your answer is that the point ABC are collinear. I'll repeat myself. If you can find determinant of the using those points, coordinates ABC, and get that value equal to 0, means the points are collinear. Okay, 3 points A, B, and C with their coordinates given are collinear if area of triangle, or basically determinant value, is 0. Basically determinant of that value, written in this format, is 0. Then the points are collinear. Okay, so this is clear. Got it? Now question on this. Let's solve a question on this. Find the values of K if the area of triangle is 4 square units and vertices are given to you. Area they have also given. Okay. Area of a triangle 1 by 2. They've also given the vertices. Vertices. So first is K0, second is 4, 0, and we have 0, 2. 0, 2. And what is this going to be? 1, 1, 1. 1, 1, 1. Okay. And what happens here? Please check. Area of triangle, right? This is given as 4 square units. So right here 4. 1 by 2. Determinant of same thing. How do you find determinant of this thing? Let's find across column number 2, because we have 0, 0, 0, right? We have 0, 0. Okay. When I do that, please check. I can don't have to write across 0, because we're gonna get minus 0 something, doesn't matter. Again we get plus 0, doesn't matter. And last will be minus 2. For this I'm going to erase the second column, third row. What I have? We have the matrix over here as, please check, K1 and 4, 1. That's my matrix. Okay, that's my matrix. Alright, bring this 2 on this side. We get 4 into 2, which is 8, equals to, find a determinant, right? So we have both signs possible. Okay, because area can be positive, or area can never be negative. That's why we have to include both signs under the operations. Okay, so now what we have left with, simply here please check, we have 0, and this will become minus 2 times of K into 1 is simply K, and we have 4 into 1, so minus 4, right? K into 1 and 4 into 1, so K minus 4. It becomes here what here? Minus 2K plus 8. Minus 2K plus 8, this is going to be plus minus 8. Okay, minus 2K plus 8 is going to be plus minus 8. Why plus minus? Because of the determinant operation. Area is never negative, so both can be, whether it is minus 8 or plus 8, answer will be always plus 8 only, right? That's why we've taken both the operations. So let's use one at a time. We get plus 8 equals to minus Q plus 8. This cancels, I get K value is 0. Yes or no? Minus 2K equal to 0 means what? K value is 0. I'll repeat myself. If you take the plus 8 sign, 8 and 8 will cancel. You have minus 2k equal to 0. It means k value is 0. Next one, we have minus 8 equals to minus 2k plus 8. Being 8 on this side, we get minus 16 equals to minus 2k. Cancel these two, we get 8 over here. Hence k value is 8. These are simple calculations. I know you can do it. Please have a look. Question number 5 is done. Answer is k equal to 0 or 8. For any of the two cases given to you, either 0 or 8, area will always be 4. When you take 4, it becomes negative 8. When you take k as 8, it becomes negative 4. When you take k value as 0, the area comes out as positive 8. Basically, positive 4, basically always positive only, not negative, because area can never be negative. But yeah, operation will be minus 4. You have to make that to be positive. Area is always positive. Have a look. This is clear. Answer is 5. Done. Okay. Now question number 6 will be your homework. Right? Similar question. Find the value of a k if the area of triangle is given as 3 square units. Okay. And the points also given. This is your homework. Comment your final answer. Okay, so I have total given 2 questions to you as homework, question number 1 and question number 6. If you are watching this video for the, let's say starting from here only, then please go back and give me the answer for question number 1 also. Homework is 2 questions, question number 1 and question number 6. Give me your answer in comment section. Okay, you'll do it? Yes. Question number 7 now, if the points A1, B1, A2, B2 and A1 plus A2, B1 plus B2 are given collinear. Okay, there's a point like this, A, B and C. We have this coordinate is A1, B1. Here we have A2, B2. Here we have A1 plus A2, comma B1 plus B2. They're saying they are equal to, their collinear means their straight line. How do you find that? Area is 0. Write that. A1, B1, A2, B2, A1 plus A2 and B1 plus B2. This is 1, 1, 1. Okay. You have to find this equal to, what equal to 0. Because their collinear means the determinant will be 0. Okay. Find it out. Across, let's do it across first row only. So we'll get for the A1. For A1 what will happen? I'll remove this 2. I get B2 into 1 is B2 minus the sign B1 plus B2. How come, sir? B1 plus B2 into 1 is how much? B1 plus B2. There's a subtraction, that's why there's a minus sign. Next comes what? Your B1 comes here with the minus sign B1. 1 second. This time we have to remove and erase the second column. Erase the second column. In this case what we have, A2 into 1 is simply A2 minus, and for this case we'll have A1 plus A2. A1 plus A2. Last one is what? Your plus 1. You have to remove the second row cancellation, second column, sorry, and cancel the third column. Third column you remove, what do you get? Please check. A2 into B1 plus B2, and we have minus B2 into A1 plus A2. A1 plus A2. Okay, let's simplify this. First of all, this is equal to 0, right? Yeah, this is equal to 0. Please check. Okay, let's continue from here. What we have, B2 and B2 is cancelled, A2 and A2 is cancelled, correct now? A2 minus A2 will be cancelled. Same here, B2 and B2 is cancelled. What I get? A1 times of minus B1, first element is this, minus sign, B1 times of, this is going to be what, dear? Minus A1. Okay, and over here what we have, expand it, A2B1 plus A2B2, there's a minus sign, B2A1 and minus B2A2 equal to 0. Have a look, this B2A2 and this A2B2 cancels. Here also minus A1B1, here this is plus, this becomes plus A1B1, cancel. Correct? Minus A1B1 and plus A1B1 cancels. We have here A2B2 cancelled. My answer is what? Final answer is coming as A2B1 minus B2A1 equal to 0. From here you are getting what? A1B2 equals to A2B1. How come, sir? Move on this side. The answer is A1B2 equals to A2B1. Option is A. Have a look. Option is A. Question number 7, option is correct as option A. Got it? Clear? 7th is done. Question number 8 now. Alright. You can download the class notes from the WhatsApp channel. Don't forget that. It will be uploaded today only. Once the session is complete, you can go ahead and download the session's notes. If ABC is not equal to 0, they have given that ABC product is non-zero, and the determinant of this is given as 0. They are also saying that A par P, B par Q should be there, I think, yeah. B par Q and C par R. This is the correction here, please check. This should be B par Q, okay? And plus C par R is given equal to 1. Then find the value of P plus Q plus R minus 1. P plus Q plus R minus 1. Sorry, minus A, not minus 1, minus A. Okay, this is A par P, B par Q actually, and C par R. Please do the correction. Okay, so they're saying that this determinant is 0. Let's find that. We don't have anything else to start from. Let's find the determinant from here. Okay, so we'll start from here. 1 plus A. If you do that, we're going to remove this 2. We'll have 1 plus B into 1 plus C. We'll have 1 plus B into 1 plus C minus 1. Okay, and then comes your second column. Then comes your second column. Okay, you'll have a minus sign for this. So you'll have minus 1 times of, have a look, 1 plus C into 1 plus, sorry, 1 plus C into 1. So 1 plus C only, and 1 into 1, so simply minus 1, right? Please check. 1 plus C into 1 is simply 1 plus C, and 1 into 1 is minus 1. Okay, subtraction is there, 1 plus C is there, and the last one will be plus 1 only. We'll have to cancel the third column. Cancel the third column, right? I hope you know that by now how we are finding the determinant. That's not a problem. Okay, 1 into 1 is going to be simply 1. This time we get minus 1 minus B. Minus 1 minus B. Please check. How come, sir? 1 into 1 is 1, and 1 into 1 will simply, 1 into 1 plus B will be simply 1 plus B. There's a subtraction, so minus 1 minus B. Okay, so 1 and 1 is cancelled, 1 and 1 is cancelled. What else we have? Expand now. 1 plus A over here, and for this side we get, expand it, so we get 1 plus B with 1 is simply 1 plus B, and 1 plus B with C will become plus C and BC. This is a minus sign. Over here we have plus C, okay, sorry, minus C actually, and minus B. Sorry, this is a minus C. How come, sir? From a minus sign outside over here. Please check, this is a minus 1, right? Multiply this with C becomes minus C, and this is simply 1 with minus B becomes minus B. Okay, and 1 is cancelled over here, right? 1 and minus 1 is cancelled over here. Do the multiplication of this. You get the result as 1 plus B plus C plus BC minus 1. Okay, so multiply this whole thing with 1 first, you get same thing, B plus C plus BC. Multiplying this whole thing with 1 first. Now we're going to multiply the whole thing with A. So plus, I multiply A with B, I get AB, A with C, I get AC, and A with BC, I get ABC. And minus C minus B I have. Minus C minus B I already have. C with minus C is cancelled, and B with B is cancelled. B with B is cancelled. Okay, so we have that already. Great. Now what is we are getting? We left with here BC plus, excuse me, we have BC plus, I'll write here BC plus AC actually. Check this out. I'll write here BC plus AC plus AB plus ABC equal to 0. And this is all equal to 0, right? They're given that equal to 0. This also is equal to 0. Given the determinant is 0. The given determinant is 0. Okay. So now I'm going to do what? I can see we are having ABC is non-zero, means I can make a factor over here with ABC. Let's take ABC common. Let's take ABC common. Let's take from all the 4 terms, let's take ABC common. So there's no ABC over here. We know how to factorize that. We'll have 1 by A left in this. For this you'll have 1 by B left. And for this you'll have 1 by C left, and we'll have plus 1 equal to 0. Correct now? 1 by A into ABC, how much is that? BC. 1 by B into ABC is what? AC. 1 by C into ABC is what? AB. Okay. This is not equal to 0. This is non-zero. It means this part has to be 0, so that the whole thing is 0. What I get from here? A power minus 1, B power minus 1, C power minus 1 plus 1 is equal to 0. Bring this 1 on this side. I get A power minus 1, B power minus 1, C power minus 1 is minus 1. Compare this with this now. This with this now. What are you getting? You're getting P plus, getting P equals to Q equals to R equals to minus 1, and even A is equals to minus 1. Answer you check over here. Minus 1, minus 1, minus 1, and we have minus of minus 1. How much I get? My final answer is coming as minus 3 plus 1. How much is that? Minus 2. That's my final answer. Option has to be B. Option has to be B. Okay, got it? Option is B, correct. So I have done a little bit lengthy this approach because I wanted to explain you everything. But if you want to make a shortcut out of this, what you have to do, check this out. From this step, right, from the first step only you can identify that something is getting cancelled. Okay, what is that? Please check. This is very clear, right? This is very, very clear. 1 and 1, only C and B is left over here with the minus sign, and over here we also have C and B that will be cancelled. You can see AB pattern is there, AC pattern is there, BC is there, and we also have to multiply ones together, we get ABC. Means we don't have to do the exact expansion to get the result as BC, AB and AC with ABC. How come, sir? BC is there, AB is there, and AC is also there, and with BC you have to multiply A to get ABC also. So it means 4 terms will be there. You don't have to do the expansion to get the result. Once you get this term out, it means you can clearly visible from here. ABC taken common, you have 1 by A, 1 by B, 1 by C. That's the same expression given over here. It means it is minus 1, minus 1, minus 1, and minus 1. Answer becomes simply equals to minus 2, which is option number B. Okay, so no need to do the step number 3 and 2 over here. Only step number 1 is good enough. Then you come to step number 4 over here, and then the final answer comes. Got it? Question number 8 is done. I have written everything so that there is no confusion to be present in the session. Okay. 8th is done. Question number 9 now. All right. Now this is the last question of the day. Let's solve it and complete our session. What this question says: evaluate and determine the determinant given to us. There are a lot of logs over here. Okay. But we have to use some properties of logs before I get to the determinant first. Okay, so determinant will come later. Right now we have to go to the log part first. So we have power 512. Can we write in the power of something? Yes, let's do it. So we have here log of 3 with the number 512. This will become log of 2 power 9 and with the base 3. Remember 2 power 10 is 1024. So 2 power 9 is 512, which is half of that. So from here I get 9 log 2 by 3. 9 log 2 by 3. Okay. So any useful to us? We'll see that later. Right now this is clear. 9 log 2 by 3 is clear. Okay, sir. What next? Yeah. Now again we can simplify. Can you simplify this part? Log 3 with the base 4. Can we do something about it? Yes, we can. We'll see. A log of 3 with the base 4 is given by what? You can write this as log of 3 with the base of 2 square. Okay. Any power of the number itself, 3 power, will come in the coefficient as the numerator, and same over here, this 2 will come in the coefficient as but denominator. So 1 by 2 will come. This 2 over here, this power over here, this 2 power of the base itself will come as the denominator of the coefficient. This comes, this is clear. Okay, so that part is clear now. Next, this one, sir, this is easy one. So log 8 with the base 3 becomes log of 2 cube with the base 3. So simply 3 log 2 with the base 3. 3 log 2 with the base 3, and the last one is log 4. So log 9 means log 3 square and log 2 square. So we get what here? 2 by 2 log of 3 to the base 2 cancels. Okay. My final answer is simply log of 3 to the base 2. What did I do over here? Please check. So I can write 9 as 3 square and I can write 4 as 2 square. This 2 comes out as the numerator and this 2 comes out as the denominator. They cancel each other because they are the same. Answer is log 3 with the base 2. Okay. Let me just write the 4 elements highlighting each other. My first element is this one, second element is right over here, third element is over here, and fourth element is over here. Let's write the matrix now. So determinant will become what? 9 log, what is it? 2, 3. Then we have 1 by 2 log 3, 2. And over here we have third term, 3 log 2, 3. And we have this over here as log 3, 2. As log 3, 2. Okay. How do you find it? We have to do the cross multiplication to find the determinant of this. Listen to this. Last step. Determinant equals to, please check, 9 log 2 with the base 3 and log 3 with the base 2. There's a minus sign, of course. There's a minus sign. And we have 1 by 2 into 3. Let's multiply the coefficient first. 1 by 2 into 3 is simply 3 by 2 right here. 3 by 2. And now multiply the logs together. So we have log 3 with the base 2 and log 2 with the base 3. There's a property, remember, whenever you have this common, whenever you have this 2 and this is common, this 3 and this is common, answer will be simply what? Log of this with the base this number. So my determinant is going to be 9 log of first term 3 with the base of the first one 3. Minus sign, again 3 by 2 will come, log of this number 2 with the base of this number 2. Log a with the base a, what is the answer? 1. Log a with the base a is 1. Hence answer is going to be 9 into 1 minus 3 by 2 into 1. Take LCM, LCM is 2, 9 2s are 18, minus 3, answer is 15 by 2. Answer is 15 by 2, option A is correct. Excellent question, please check. Simple calculations but out of the box. So excellent question, have a look. Question number 9, option A is correct, 15 by 2. Yeah, so this completes our session today, and I hope you liked it. Any other feedback you have, anything you want me to add in the sessions, let me know in the comment section. So that's it. That is it for today. I hope you've enjoyed it. If you're new to the channel, please subscribe to the channel, because we are here to deliver quality content and very serious content for your preparation. There's no jokes going around here. Very much serious about your preparation, very much dedicated to your, our team over here at Diksha Karnataka is very dedicated to provide the best content possible, the best lectures possible for all of you. Okay, so any other thing you want to ask us, let me know in the comment section. Okay, not only for maths, for other subjects also you can let me know, and we'll just pass your message to your respective teacher. Okay, and with this I can end the session today. I'll see you again very soon. Till then, take care. Bye bye.